Cool. Well, welcome back, everybody. Glad to see some of you guys have made it in for this last set of tutorials before our presentations this afternoon, evening, later this morning, whatever time zone you're in. I'm Jessica Scheick. I'm a research assistant professor at the University of New Hampshire. And I am a glaciologist and a software developer, the two hats that I primarily wear. And I have been working with the SnowEx the Hackweek teams for a number of years now, both as a participant and as a tutorial lead and as an organizer of various Hackweek events. And so I'm here to kick off our session today on open science and open source software, and to talk a little bit about the community aspect of that and my role in that. So to start with, and because I know everybody is super duper tired and probably not taking in a whole lot of information at this point, we've put together some resources for you all that'll include a lot of the information that I'm talking about and sharing. The idea is also too that these are resources for the long term, not for, not things that you're necessarily going to memorize all today, but they're great tools and things to think about in the longer term as you work on your research. So first, the question that I often get a lot is, and one that I didn't know the answer to even fairly recently, was a couple years ago, was what is open science? What does that mean? We all talk about open science and open data and open source software, but what does that really mean for our day-to-day and throughout our careers? So in the tutorials for today, we've got this quick document here that talks about, well, what is open science? Open science is the process of making science open and accessible to everybody. And we do that through making our data and our analysis reproducible and available. And we do this through a number of different mechanisms. Some of it is by posting our data publicly, some of it is by posting our code publicly, and some of it is by posting our research results publicly. But it's more than just sharing those things completely openly. It's sharing them in such a way that makes them accessible for other people, right? Micah could have created this great SnowEx database and not told any of you about it. And that would have been cool, but it's cooler because we all know about it and know how to use it. And he put the time and effort into sharing that information with us. And so that's a really critical step in the open science process. But as you've no doubt learned this week, there are also a lot of tools, techniques, and challenges to making your science open. It is not an easy task, and it is not something that you can make happen instantaneously, much as that would please everyone, I think. And so on this page here, and I won't go into these in great detail, are some of the great resources that you can find that will help you practice open science, but through the lens of a scientist. And they'll help you build the skills, but also the community and support that you need to effectively practice open science. It's something that's really hard to do in a vacuum. So I can talk about each of these really quickly. The Turing Way is an institution in the UK, but they have a really great online resource. It's actually a Jupyter book. Obviously, anyone is welcome to contribute to it, but it's got a lot of really great guides that are sort of nice bite-sized chunks for how do you think about approaching this aspect of open science. So it ranges all the way from the basics of what is Git and version control to how do you use Git? How do you collaborate across cultures or time zones? They're constantly adding more and more really cool materials to it. Another organization that I found really helpful is the Center for Scientific Collaboration and Community Engagement. And this group is really focused on the community aspect of open science, which is critical, as I'll talk about in another minute. And then I won't go into the rest of these in the interest of time, but I encourage you to check out all of these different groups, check out the resources that they have available. A lot of them also have conferences, some of them have fellowships, or different programs that you can use to shape your research and shape your work in a direction towards open science. And so the other thing that I wanted to talk about for a minute, and I don't really have any like great slides or notes for this, so I'll go ahead and stop sharing. But actually that's not true. What am I talking about? It's been a long week. So the other piece that I wanted to share is the role that I have, which is, and I know many of you were at the ISAT2 Hack Week last year. I know many of you have probably heard throughout the past couple days about a library called IcePix for getting ISAT2 data. What you might not know is the origin story for that, which is it actually came out of a Hack Week project. A couple years ago at the first ISAT2 Hack Week, shortly afterwards, I got together with Anthony, Fernando Perez, and Lindsay Higgy, and a couple of other folks who were at that Hack Week. We've maintained a really strong connection with NSIDC through Amy Steicher. And we said, okay, is there a way that we can formalize this effort to really effectively share our code? And so what I've been doing for the past couple of years is building this collective library, but also trying to build a community around the activities, building the skill sets that are required for all of us to get the skills and training to participate in collaborative open source development. If anybody else's experience is similar to mine, that was something that was starkly lacking from their graduate training. And I've had to teach it to myself with the help of many of the wonderful people on this call guiding me. And so one of my primary roles as the IcePix community manager is to really try and build that sense of community and empower everybody to participate in collaborative development, open science, in whatever way is most comfortable for them. And if that just means that you've told us that there's a typo on our documentation page, that's still important. That's still a critical piece of information that we didn't know without you telling us. So, it sounds a little soapboxy, but no contribution is too small, and everybody is able to contribute. And what we really want to do is empower everyone to have the tools and resources to contribute. And so with that, I think I'll turn things over to Joachim and let him talk a little bit more specifically about the open source software component of open science.
Cool. Well, thanks, Jessica. I definitely like your graphic a lot about the open science. I never really conceptualized it or seen it in such a good way there. So I hope also people really see that as well and see how there's so many components to all of this, and we just scratching the surface right now with our little intro right here on what is able or what is even out there for us. So Jessica said, I want to go now a little more into a technical nitty gritty is when you first hear open source software. And I'm going to start sharing my screen here. So this is again Jessica highlighted day 5 open science, and I'm going to the open source software part. And Jessica just started with how can we as individuals now being part of this week, or just having learned Python this week, feel that we can contribute in a meaningful way to a project. And I want to expand the horizon there a little bit with the first couple of bullet points that are down here. Is there's not just code, in an open source and open science approach. There's a lot more. And the first 4 or 5 bullet points right here is for instance, start reporting bugs. So we all use now the software. We're all now users to it. And maybe we ran into an issue, which we can just, now then document for the maintainers of any really project there and let them know, hey, there's something that doesn't look right. Or on the other hand, it doesn't necessarily just have to be a bug. Maybe there's an enhancement. You say, hey, look, the function or feature you gave me right there is really cool. I just wish, you could add this little tweak right there, and it would be so much more helpful for me, or maybe also helpful a lot more because we collaborate among each other. and you agreed maybe, hey, this should be something that needs to go into the library. It's kind of like a way to start getting into a library or into a contribution kind of flow. Next thing, as Jessica said, there is also no documentation. Like you have used the library now or other libraries, and something maybe didn't click with you, or something you said, hey, I wish they would have explained it a little different. Suggest that, like there's no harm in saying, hey, this is what we experienced. This is like how we saw that could be better. Improve the documentation, and this will help you and among others then to then future make even better documentation, so we all kind of have the different angles for something to get it and understand it. Other thing I have put out there is like help other users. So now maybe you've heard the first time X-ray, and now you go back to university after that, and you find a new student as well there, or a co-worker, collaborator, whoever it is, like who wants to get into X-ray but doesn't really know how it is, and you can now be an advocate for that library, saying, hey, look, I had this great experience at Hackweek, and I knew how, like they showed me how to use it. Let me walk you through this notebook here. Now you can be like almost what we did for you. You can step into a kind of like instructor role and say, look, this is how I learned it, and I think this was helpful. So you can take the notebooks and distribute them. And this is also how you contribute to the open science and sources approach, where you say, I step in now into the educator role, and I'm gonna take that knowledge and spread it so people can benefit as we are do right now. And then if you really kind of feeling like motivated and say, I think I got the chops as well, I get this library a little better, you work for a little more weeks, you step into the source code, there are things like the good first issue thing. So GitHub, has this issue page, which I can show you here on, let's say, the SnowEx SQL. So if you go to a package now, and then you see there's an issue tab right here, and look, Micah did a good job of labeling all these things, like the issues that he thinks are relevant. And sometimes, GitHub also has labels that people use that says it's a good first issue. I guess we still don't have it yet, but there will be other projects, for instance, that will label things like that are kind of the intro drug, I call them, to, okay, I think I want to get this now, get a little more involved. So this is how you can get started right there and fix your first little issue. And then I tell you, it feels really good once you get like any contribution to a new project in, and you see that PR being merged or that pull request. I think everybody kind of gets this first like, wow, really, I did it. And it wasn't even that hard in the end, right? And then there's also like what Jessica said, attend meetings, attend like workshops, or participate in weekly calls. I think we all learned through this pandemic how we can also organize ourselves virtually as a bigger global community. And they're announced on their discussion forums maybe or somewhere else. And you can also just listen in and be part of that way, to say, hey, I think I have this idea, or just listen in and get familiar with the package that way by getting to know the people around there in your community. It's like what we try to throughout this whole week right now, be part of the community, create one, expand it. And this is also how you contribute to open source software, by being part of it that way. There's also kind of, if you really are now into the chops of saying, okay, I now want to get my own little package out there. Jessica mentioned like the Turing way. They have also like a definition of how you start your own project, like as an open source project. And also GitHub itself has another kind of guide for that. So these are kind of just two references we gave you right there in order for you to get started. If you with maybe your project team right now, you put together like a set of libraries you think they're useful for others, and you want to turn into something like bigger so others can use. These are like some two guides that we put out there to help you kind of establish this project as turning into its own library right there. And last but not least here, before I hand over to Micah, and like he will show you little things, more technical details, what we did with the SnowEx SQL there, or he did, by the way. He was like really the man behind this whole effort here. There are a few elements I would recommend for people, or we recommended over the years as a Hackweek, to say this like makes a good kind of foundation to build your project into something bigger. And you also have these elements in your sample repository, which is, I think a lot of you maybe have forked it or used it for your project, but I just want to highlight one more time. So there is the sampler project repository, where we kind of, so there's a README file. And the README, is really something like we put in there. It's like, tell people what your project is all about. Start communicating, start clarifying things, like introduce yourself. Like you walk into a room, you walk into a new kind of community, you tell them, okay, hey, this is the project, this is who is behind it, this is what we're trying to address with this project right here. The next element I put on this page was the contributors guide. So now that you have a community out there or you have your project, and we haven't done it for the sample project, but if you're in, for instance, we'll go later to Micah, to the SnowEx schedule, there is a contributors guide that tells you, okay, you want to get involved? This is how you do it. Kind of open the door to others and tell them, you want to get involved? This is how. Next I put out there is some tests. So this is a really technical detail. A lot of projects, you know, they want to ensure once they get out there and people start using it, that once you start changing code and you want to update logic, that you don't break existing implementations of your library or usages. And this is something that's called tests, unit tests, that help you ensure, you know, that future improvements of your library also support the early adapters. You know, the ones that started to help you early on don't want to be surprised by a new release of you to say, oh, and now all this function went away or this parameter changed and you didn't tell me about it. So tests are really a good way, like a warning system, and also a quality control way to say, okay, let's make sure we don't infer surprise when people use your project there. Other thing, I mean, and that's where SnowEx and Micah showed you, I think, this tutorial there, documentation. I mean, documentation, it's like if you're more of a tech-savvy person, you like to crank on the code and you like really try to make this new feature happen. There's also a lot of benefit, like if you document it, because if no one knows about it or no one knows how to use your stuff, like your adaptation rate will be pretty low. And also your barrier of entry will be so much higher unless if you really put your documentation in there, explain things and how to use it, you will enable a lot more people that way to really be able to use your code. And like we said earlier, this is also an easy way now for people getting into your project, because if they see documentation is needed, then they contribute it if they have a starting point. So at least, you know, I would recommend make a good starting point for documentation. And this is something that the community can involve there with you. Other things, it's like a little more technical then. There's also code conventions. So, you know, we all have our different styles and different ways we like to program, but there is some established kind of patterns and naming variable conventions and stuff like that. This is that we also recommend for a project there, put or let people know how you would like to see things, you know, being kind of styled in a code style. PEP8 is like a very big keyword, for instance, for the Python community. So this is kind of a standard, and there's other libraries that will help you to be compliant, almost so to say, with those recommendations. So then, you know, you go to project A, project B, or project C, and it doesn't really matter what kind of like code you're looking at. They're all kind of at least styled in a similar way. So the comprehension is a lot easier because the style is the same. It's only let's say, but it's the logic that's most, you know, to understand, instead of just also trying to figure out, okay, he's naming it that way or that way. I don't really know what he means by that. This is kind of like establishment of standards there. A license, every good open source project has a license. I don't want to go into legal stuff because I think you're gonna all fall asleep, including me. So here's like a page that shows you like all this cryptic, you know, what does that license mean? This page right here, TLDR Legal, does a good job of explaining it as they claim it into the layman terms. So let me know if you think differently and we change it there. But anyhow, last also two components before I'm gonna hand it over. I guess I have two more points. One second, Micah. There's also kind of a publishing your package. So you all learned how to execute that pip command. And pip is also just, you know, an open kind of repository for all these packages you can publish there. Conda is another way. People maybe have heard of it. If you're new to it, I put a link right there. It's another kind of way to publish your package. And then the last component I also want to highlight is like organize a community on a platform. Like we started here with Slack, and there's also a thing like Discourse. And for instance, IcePix and Jessica is active there. She's like maintaining a forum there to organize your community, announce things, get together. Like this is kind of a way of a personal way to start your little community outside of code there in another way. I put like development environments. What do we mean by development environments? So we know Jupyter now, we all hacked it all week. It's kind of the way we showed the code. And there are other ways if you want to ever gonna beyond Jupyter Hub, which is definitely still a great tool. And there's like local environments, or also called integrated development environments, or IDEs. I put a couple links right there. This will also help you manage your code, write code. They are a similar kind of fashion as the Jupyter Hub, and have code completion, syntax highlighting. It's just something more local. If you have a big package, Jupyter Hub, in my experience, can be it can outgrow the hub, so to say. And if you need a bigger kind of management environment, these are kind of three combinations right there. And last but not least, Jessica also had a really cool little Git interactive learning environment there. So we put it out there. This is kind of, if you want to not destroy or don't be bothered by putting a GitHub repository up just to play with it, this is kind of a last learning interactively environment on the web, where you can go ahead there and try things out and try to break things. And they will be one-to-ones, as we have with the real GitHub. All right, so there was a lot of kind of paper, I want to say, knowledge here, but so let's turn it over to Micah, and who will just walk us through like more little specific on how SnowExSQL include all these elements I just showed you. So Micah, if you're there, take it away from me.
Yep, thanks. Okay, so we started work on SnowExSQL last May, and this is, I think, repo number 10, Python library number 10 for me. So I think it's probably my most polished one. And I think the important thing for folks when they're thinking about setting up their own package is just try it. Like my first package that I set up was a mess. It didn't install for anybody but me. But I think that's important because you start to see pretty quickly places you can iterate and change, especially as you start to share code. So I think the first prompt is just make a package and try it. That's probably the best advice you can get from this. Let me share my screen. Okay, so this is the SnowExSQL repo. You guys can all see my screen, right? Oh, you want it bigger?
Maybe increase the font for a notch or two.
How's that? Is that better?
Yep.
Cool. Okay, so in here, you can see some of those elements that Joe was talking about. Here's our docs. And this is the actual where all my source code lives for the Python package. And then here's my tests. The docs here are just, I use Sphinx to do this stuff in tandem with read the docs. And read the docs is just a place that hosts all my documentation. A lot of these files are just text files that use RST format. So there's not a whole lot to it, but they are really important, especially for what we're doing and trying to engage with open science and open source software. You know, in here, there was in some places in the database, we had to do some things to kind of jockey data around. And that stuff's important for provenance and other things. So I wrote those notes down so that people like you guys who go and look at it could go, oh, this isn't the full SMP profile. This is the subsample to every 100th. Stuff like that's really important. You can put in as many as you want, and there's also some tools for auto-generating some documentation. So if you go back into the repo, and then let's say under my batch here, you can actually auto-generate this stuff. And this is, Joe was talking about how to communicate, you know, what functions are available and how to use them. This stuff can be done at the level of code as you're writing. A lot of times I see people want to put stuff up here at the top in comments, and that won't always get generated correctly if you don't have it formatted in the way that like Sphinx and read the docs want to see. But what this ends up looking like, if I go to my read the docs, you can see my API documentation, and that's just a reference to all the code that's documented from those doc strings that you saw in that function there. So I can go here and go to my batch module. And then right here, I can see that same text formatted and put into a way here. There's a couple of ways to do this. I don't think that there's one particularly better than the other. I think just pick one and try to stick with it. But this is really nice because now I don't have to go to the source code to see how to use this batch base class or this upload profile batch. The other thing that you'll see in packages a lot are tests. And I really have to implore people to use tests. It's actually a really great thing to have because it checks whether your code does what you think it does. And the smaller chunks that you can make those to check those things, the more resolved and more confidence you can have in it. And that was a really big thing for this repo because we were building a database from published data. And I wanted to have as much confidence as I could that the data I took from the NSIDC is the data in the database. And there's not anything messed up unless we knew about it, like with the SMP where we downsampled stuff. There's also some tools that you can use to highlight what your test coverage is. And in this case, SnowEx SQL has a 91% coverage. So 91% of the code base is covered by the tests that I have put in into here. I think sometimes people can get kind of hung up on how to write tests and stuff. Again, I think it's like the package. You just want to just start trying it and you'll find pretty quickly how to fine tune it and make better tests. The other thing I want to talk about is Python package structures. When I first made my own, I really didn't know where to put things. Like, where do I want to put a module that I can actually import? Like, if I want to do import SnowEx SQL.batch, where does that batch piece come in? Under a simple library like SnowEx SQL, you can just have all your modules in Python scripts like this. And then when you go into them, you just have functions. It's important to not have code outside of functions or classes because when you import these, it's going to execute this to define all these things. So if I had, like after results here, if I had a print statement that was outside of my function, it would print that every time I imported it. So it's good to try to collect all your stuff and put it into defined Python structures. If you're going to do this and make a package, which I really encourage you to do, I'm a part of the microstructure project, and I'm already seeing some potential for having that turn into a package that I can use after this. If you're gonna make a package, you have to have this underscore and it underscore, and that just tells Python to look for these as imports. Outside of that, you'll hear terms like continuous integration. These are kind of a broad category of things that describe when I push code, certain things happen and then it gets deployed or brought back to me. In this repo, I have GitHub executing my tests every time we get pull requests and every time I push, just to make sure that we're not breaking anything. And that's a nice thing for you as a developer who wants to contribute. You can push code and know whether you're going to break other people's code. And that's part of what makes this a stable community interaction. There's a lot of other tools for continuous integration, and you can, like, the sky is the limit for doing stuff. You can deploy to PyPy and have your pip packages automatically after passing some things. I see Paul's got some questions like cookie cutter. Yeah, I use cookie cutter. I was actually going to talk about that next. That's what I used for this project. I typically kind of pair out some things and put in some of my own stuff. But cookie cutter is just a script that asks some questions of you, like what do you want to call it? Where do you want things to be? What kind of license you want? And then when you finish answering those questions, it will build this Python structure for you. It's not just for Python. You can use it for other things, and you can even build your own templates. But for those who are curious, there's a really great documentation on how to do cookie cutters. I've used them. I've made cookie cutters to set up modeling basins and stuff like that. They're very handy and super useful and helps kind of get folks off the ground when you're first starting with your own, when you're setting up your first Python package. So certainly take a look at this if you just want to try to convert what you're doing for Hackweek into a package. Just build one of these and see what's inside of it. There's going to be stuff in it that you probably won't understand. I didn't for like 2 years after using this. There was stuff in there. I was like, I don't know what this does. I'm just keeping it. Yeah, that's a great question, Paul. Thank you for asking that. And then the final thing I want to just kind of like plug is Provenance and reproducibility. That's a big part of what we do. And I don't know how many people saw this paper. It's a commentary that went into WRR about how most computational hydrology is not reproducible because there's all this stuff that we end up doing to set up what are, whatever analysis we're going to do, and that part of it ends up being very closed. So this idea of open science in open data, these are all things that people are talking about and trying to figure out how to overcome. So I would really encourage you to think about that as you're building even what you're doing for Hackweek right now, and ask yourself, could somebody just blow away this whole repo, download it, and start from scratch and actually get what we're getting? That's a really important question. And I've tried to do that in SnowEx SQL. A lot of that lives under scripts. And I have download scripts for downloading all the data. So like downloading off the NSIDC, downloading the ASO data. And then I also have upload scripts that describe how I'm uploading those to the actual database. And the whole point is to have kind of this like cookie crumb trail all the way to the end use data. So that's important stuff for you guys to think about. Outside of that, I think that's all I got. Did Joe, did you have anything else to add to this?
No, I think if people maybe have questions for that or want to see a little more specifics, I think this could be now a good chance to start pinging us. Or I know if there's no question, maybe Jessica can do a quick kind of discourse display of the ice picks if people are interested in that. I'm open to anything really for the rest 10 minutes now.
I'll ask a quick one, and I would love to see the ice pick stuff, but Micah, can you give a little more example of like what kinds of things the tests are doing? Or
yeah,
I guess I don't quite have my head wrapped around like what you're testing when you run through all those tests.
Yeah, here, let me share my screen again. That's my share my screen noise, if you haven't picked up on that. Okay, so I have this test folder. I use PyTests in here. There's a couple of different test frameworks. They sometimes are pests. PyTest goes to look for my tests in here, and that's how it collects them. For an example, let's see if I can find. Yeah, so let's see if I can find a little bit simpler. String management might be a good one. Yeah, so here's a good function that is fairly straightforward. What I have is a function called Parse None. And in a lot of the data, there's a lot of different ways people were trying to represent no data or none and stuff like that. And so what I used is this function to basically do that for all the data sets wherever I found keywords that I knew were to be none. So here I test with strings nan and none and even empty in some cases, and then np nan. And then I make sure that my parse function can interpret those as none, the Python object.
Perfect.
And so this assert just says, make sure that this is equal to this. And if it's not, then it throws a big error. So a lot of times it's really just about, I have some expected outcome from a function, and I will want to know, is it doing that? And sometimes I hear people talk about test-driven development. So as I'm, say, building a script or something, I know I've got a couple little chunks of code that I'm gonna use in, say, this script. So what I can do, for instance, in this case, is build a test for Parse None before I've built Parse None, and say, here's how I want it to behave, and then go and run, write the test or the function, and then just keep trying my test on that until I get what I need. That's sometimes tough to do right when you start a new project because there's just a lot of pieces still floating. But I think after you do kind of your first code puke, it's a really great place to start adding things, is going, okay, I'm going to build this test, and here's how I want it to behave, and then start writing the code that matches that.
Perfect. Super helpful. Thanks.
Yep.
if I maybe add quickly onto that, that whole test-driven approach is basically an industry standard now for any software development shop. So if you think you're interested in a more sort of software-oriented career, this will be part or should be part of your resume. And I think it has evolved over the last 10, 15 years there, that there is, this is part of a developer toolkit to know how to write good tests. And it's also kind of part of also documenting as well, I want to say, because if you can show, I have run through those scenarios and my function still supports those scenarios. And also people can go in there and say, hey, did he think about that, thinking about that? And that also goes maybe back to another kind of contribution option here. If you want to get started into a code, start changing tests and start manipulating those, because you will quickly discover, okay, oh, this doesn't work with this function. Why doesn't it? Should it? And can I, improve it that way? So tests are really kind of almost a low entry here to say, get to know the code a bit more and document your code. Do we have any other questions? If not, I would suggest maybe Jessica give us like the whirlwind tour of the Discourse IcePix forum. Is that possible?
Sure. I did. Somebody posted in the chat or in the Slack talking about how it is, all of these tools are great, but it can be challenging to maintain them and find the motivation to work on them. And I want to acknowledge that, because I think we're all in that boat with you. And I think that we're also very fortunate that a lot of our program managers are really starting to, if they didn't already, are really starting to recognize how much time and energy that work takes, but also how critical it is, and they're supporting it. And I think that that's really important. So, don't forget that, and, call it out as something that you spent time and energy on. Document it for yourself and for other people. And I think that can help it feel a little bit more worthwhile sometimes, when it kind of feels like otherwise it's just letting you get behind. Okay, so real quick, the last thing that Joachim asked me to share is what's called a discourse site, which is it's you can almost think of it like a Slack channel, or any kind of open forum, but it's actually completely open. All you need to sign into any of them and post something is a GitHub login, so you don't need to have a separate account, and it's completely open. Many of you are probably really familiar with Stack Overflow, which Stack Overflow is really great for solving very specific technical issues, but it doesn't often allow us to have those sort of in-between conversations. And also, that's not where you're going to necessarily find the community engagement and educational opportunities. So for IcePix, we're actually have our own little corner of the Pangeo website. So you guys have been using a Pangeo instance all week as your online hub, I believe. Maybe not. So if you were to you can just go ahead and search for Pangeo Discourse, and it'll be one of the first things that comes up. And there are a lot of people, a lot of scientists on this forum who are having active conversations about all of the various topics we've discussed. So just a lot of really thinking, how do you handle these big data sets? I'm looking at putting a netCDF into this format. Does this make sense? Like, what do you guys think? So it can be a very sort of high level conversation, or it can be a very technical, here's the code I'm using and I'm getting an error. And IcePix itself, under the science category of the Pangeo website, so it's the science category, and then we have an IceSat2 topic that's all our own space for working specifically with IceSat2 data, usually in the context of IcePix, but not necessarily. So just a place where we can share all of these various tools and resources, but then we're also where people can go to discuss issues and help each other solve problems. So a couple of the things that are on here have ultimately led, as Joachim suggested, they've ultimately led to new features within the library because a couple of people said, hey, wow, this would be really great. How do we want to do this? Okay, let's go do it. So I don't know if there was anything else you wanted me to share with that.
I know. I think for me, it was like something new I haven't seen before, before even knowing about Pangeo. So I thought it's a nice platform. I also see, Brendan just asked this question about what's the difference between using, GitHub versus a Discourse. I mean, Jessica, what do you think about that?
Well, so GitHub does now have a discussions feature that allows you to kind of have these sort of less code specific, highly technical conversations. So a lot of libraries are switching to using that. But when we were setting this up years ago, that didn't exist. And so Discourse really provided, as I said, that nice in-between space where it's not, I'm running this line of code and I'm getting an error, but it's still answering an important question about, maybe how do I approach this particular problem? And it's a much more focused group than you might find, by just Googling things, because it tends to be, scientists who are having similar data analysis challenges to you. They understand the complexities of, modeled data versus gridded data versus vector data, and what's a projection system. So you're able to get a lot of help that understands the nuance of the things that you're trying to do.
Jessica, I know you've also led these regular developer calls over the last, since this was started. Can you tell us what you've learned from those experiences?
Sure. I think I would sort of encapsulate it in two key points. One is start small and learn slow. Don't feel like you need to try and do everything at once. I am very guilty of this. But when I look back at what I could do with Git a week ago or a month ago or a year ago, I am making progress all the time. I'm always learning more tools, tips, tricks. So don't feel like you have to stop whatever you're doing just to learn these tools. Pick one, pick a small piece of it and incorporate it into your daily routine. It's like brushing your teeth. Eventually it just kind of becomes so routine that you don't have to think about it anymore, but you still get the benefits of having clean teeth. I find that Git is kind of the same way. It seems like a big chore at first, and then all of a sudden you're like, oh yeah, it's the end of the day. Before I close my computer, I Git push to GitHub, and my code is there for me the next time I need it. The second piece is don't underestimate your own knowledge and be willing to share what you do know. It's been really incredible and transformative to walk somebody through a fairly beginner exercise on GitHub or in Git, and then watch them a week later walk somebody else through that same set of steps. And that is one of the most powerful things you can learn. And just like I think it was Joachim said, if you learned Xarray, you can take that back. You don't have to be an Xarray expert to teach somebody else something about Xarray. So, yeah. How's that for a motivational,
yeah.
motivational speech?
Nice motivational speech right at the end of our last tutorial. Thank you. Let's thank Jessica, Joe, and Micah for that great session.